All right, today we're going to do something kind of cool. We're going to build a software-defined data center right from the ground up. We'll be using the VMware Blueprint as our guide, and you'll get to see exactly how all these different components come together to create one single, incredibly powerful system.
But before we start laying bricks, let's just pause on the big idea behind all of this. What if you could take all the complexity, all the servers, the storage arrays, the network switches, and just make it all act like one giant unified computer? That right there, that's the fundamental promise we're talking about, taking all that complexity and taming it with smart software.
You know, every great structure needs a rock-solid foundation. And in our blueprint, that foundation, the very first layer we're going to lay down, is all about virtualizing compute.
Okay, so this is where the magic really begins. It all starts with a piece of technology called a hypervisor, specifically VMware's ESXi. Now, this isn't just some app you install on Windows or Linux. No. This is what's called a Type 1 or bare metal hypervisor. That means it gets installed directly onto the physical server hardware itself. Its one and only job is to slice and dice that server's hardware into secure, virtual pieces that we can then build on top of.
And what does ESXi actually do? Well, it really boils down to three absolutely crucial jobs. First, it abstracts the hardware. This means your virtual machine has no idea what kind of server it's running on, and it doesn't care. It just sees standard virtual parts. Second, it's a resource scheduler. Think of it like an air traffic controller for CPU and memory, constantly deciding which VM gets what it needs at any given millisecond. And third, and this is so important, it isolates everything. If one VM has a problem and crashes, it's completely walled off. It can't affect any of its neighbors running on that exact same physical machine.
So having one of these virtualized servers is pretty great, but what about 10 of them? Or 100? Trying to manage each one individually? That quickly becomes impossible. That's not management anymore, it's just pure chaos. You need a central command center. And that's precisely the problem that vCenter Server is designed to solve. See, a single server on its own is basically an island. It's limited. But vCenter, it acts as the control tower for your entire fleet of servers. It groups them all together into something called a cluster, which creates this one massive pool of resources and unlocks all the really powerful features of the platform, which we call vSphere. And one of the most famous, almost legendary of those features is vMotion. Get this, it lets you move a live, running virtual machine, application and all, from one physical server to another with zero interruption. Your users don't see a thing. This completely changes the game for maintenance. Need to patch a server? Just vMotion everything off of it, do your work in the middle of the day, and then move it all back. This isn't just a nice to have, it's a revolution. The whole era of the dreaded 2 a.m. maintenance window is just over.
Okay, so our compute foundation is poured. It's solid, it's centrally managed. So now it's time to start framing out the rest of our structure by adding the next two layers, intelligent storage and networking.
Let's talk about storage. The old way of doing things involved this big, separate, complex piece of hardware called a SAN. It was expensive, it was rigid, and you needed specialized people to run it. Well, the software-defined approach, with VMware vSAN, just flips that whole idea on its head. It takes the hard drives and the SSDs that are already inside your servers and uses smart software to pool them all together into one shared, super high-performance resource. It's incredibly powerful storage, but now it's simple and fully integrated right into the platform.
Now, let's talk about wiring up this building and installing the security system. That's where NSX comes in. The key concept to understand here is something called micro-segmentation. I want you to forget the old model of having one big firewall protecting the perimeter of your data center. Instead, micro-segmentation puts a tiny, dedicated firewall on the virtual network card of every single virtual machine. It's like giving every single apartment in a giant building its own personal security guard standing right at the door. So why is this such a massive leap forward? Well, because that security policy is attached to the VM itself. When you vMotion that machine, the security policy goes right along with it, automatically. It also enables a zero-trust security model. And what does that mean? It means, by default, nothing can talk to anything else unless you explicitly say it's okay. You trust nothing, you verify everything. This is absolutely crucial for stopping threats from moving sideways across your data center, which is frankly how most of the big, nasty data breaches actually happen.
Okay, let's recap. We've built our virtualized compute, our software-defined storage, and our software-defined networking layers. Everything is managed by software. So now, it's time for the final piece, the capstone that brings it all together into a single, automated, integrated platform, VMware Cloud Foundation.
And this table here really lays it all out perfectly. You can see how each piece we've talked about fits in. You've got vSphere as the compute foundation, vSAN delivering that integrated storage, NSX providing all the networking and security, and then, tying it all together is the new component you see here, the SDDC Manager. That's the brain of the whole operation. It's the master conductor that handles all the automation and the life cycle of the entire stack.
And I really want you to focus on this because this is the single most important thing to understand about VMware Cloud Foundation. It is not just a bundle of software. Its real power, its primary value, is automating the entire lifecycle. It knows the exact validated versions of every single component that are certified to work together perfectly. So when it's time to patch or upgrade, it handles the entire stack, the firmware, the drivers, the software, in the right order, guaranteeing compatibility and just massively reducing risk.
So, we've done it. We've assembled our software-defined data center. The blueprint is complete. But now we have to ask the most important question of all. Why? Why does any of this actually matter? What's the real transformation that's happening here?
This is the world we are leaving behind. This is the before picture, an infrastructure built in totally separate silos. One team for compute, another for storage, another for networking. Everything was done by hand, which made it slow, incredibly error-prone, and so rigid when you needed to make a change.
And this is the after picture. This is the world that the software-defined data center delivers. An infrastructure that is totally flexible, where you can move resources around on demand. It's automated, so you can deploy entire new applications in minutes, not months. And it's completely integrated, operating as one single, cohesive system. You know, there's a quote that I think just perfectly nails this entire philosophy. The software-defined approach transforms hardware from a constraint into a flexible pool of resources managed by intelligent software. We stop letting the physical boxes tell us what's possible. Instead, we turn all that hardware into a generic pool of resources, and all the intelligence, all the power lives in the software on top.
And that right there, that brings us to the ultimate point. Once your infrastructure isn't a collection of physical things anymore, but instead it's just code, fully programmable, fully automated, all the old barriers to innovation they just fall away. You can try new things, you can build new apps, you can scale things up and down instantly. So the only real question left to ask is, what are you going to build next?